Okay, folks, let's take a look at lesson 3.2. We're on page 168, different kinds of functions. Okay, so all of these are functions. So functions can be represented as a table. They can be in the form of slope-intercept form in an equation. Functions can be graphs. So in a table, and in a graph, and an equation, basically. A table, a graph, and an equation. So now when you're looking at graphs, you have what's called linear and nonlinear. Okay, so linear would be the blue line, straight line. Linear would be a straight line. Nonlinear is the red line, so that's a curved graph. Linear is a straight line, nonlinear is a curved graph, okay? So one of the ways you can check to see if relations are functions is, again, if each x value has only one y value, so 0, 1, 2, 3, and 4, have those only appear one time, so that's a function. Each x has only one y. Or you can look at a graph and you can do what's called a vertical line test. So we can draw a straight line down anywhere on this graph, and as long as we only hit 1 point at a time, I'm doing the vertical line test. No matter where I draw my vertical line, I'm only hitting 1 point at a time. So this is a function. Okay, so again, it's called a vertical line test to see if graphs are functions. So if you draw a line straight down and you only hit 1 point at a time, 1, 1, 1, 1, 1 point. Okay, so no matter where I draw my vertical line straight down, I'm only going to hit 1 point at a time. So this is a function. Let's try this one. I could draw it there, there, there. I'm only hitting 1 point at a time on this graph. So this is a function. But then take a look at this one. So if I draw my line down here, boom, boom, I hit 2 different points. So this is saying this x value of -2 has 2 different y values. So for example, we have -2, 1, and then we have -2, what is that? 1, 2, 3, 4, 5. -2, 5. So see the x value of -2 has 2 different y values? This is not a function because when you do your vertical line test, you hit more than 1 point at a time. Okay, so let's see if this is a function. So we're on page 169. Okay, so explain whether each graph is a function. Okay, so if you do your vertical line test, and you can just imagine drawing a vertical line anywhere on this graph, you're only going to hit 1 point at a time. So yes, each x value has, I don't need an E on that, exactly 1 y value. That's why it's a function. Okay, let's look at this one. Again, this one's linear because it's a straight line. This one's nonlinear. So if you draw a line straight down, no matter where you draw it, you're still only going to hit 1 point at a time. So this is a function. Yes, folks, each x value has exactly 1 y value. Okay, so let's take a look at this one. We have this table. 1, 2, 3, 4, 5. So each x value only shows up one time. And so this is a function. So let's graph these. So let's fill this in. 1, 3, 5, 7. And then let's fill, this is counting by tens. 10, 20, 30, 40, 50, 60, 70. Okay, so let's graph 1, 3. So if you go over 1 and up 3, it's probably going to be about right there. And then let's graph 2, 12. Over 2 up 12, just above the 10 right there. And then let's graph 327, 327, over 3 up 27, just below the 30. 448, over 4 and up 48, right in there. And then 575, over 5 up to 75, which is going to be in between there. Okay, so now folks, if you were to connect the dots, connect these points, they definitely curve. So this is nonlinear because it's curved. Now, is it a function? Okay, well, let's do our vertical line test. Yes, we actually already determined that. Each x value only appears one time. Each x value has only one y value. So yes, this is a function. Okay, so take a look at this one down here, number 10. Do the order pairs plotted in the graph represent a function? Well, let's do our vertical line test. Okay, if we do a vertical line test here, we only hit 1 point 1 point, 1 point, 1 point, but then look, folks, 1, 2. When we do our vertical line test, we hit these 2 points. So this is not a function. So this x value, that's 4. That x value of 4 has a y value of 3, and then that's -3. So this x value of 4 has 2 different y values, so that is not a function. Okay, let's turn the page to 170 and just do a couple more. Okay, so a train leaves the station at a time of t equals 0, so the time is 0. Traveling at a constant speed, the train travels 360 kilometers in 3 hours. So folks, let's divide and figure out how much it goes in 1 hour. So 360 divided by 3 is 120. So that's 120 per hour. So it says write a function that relates the distance traveled d to the time t. All right, folks, the distance is going to equal 120 kilometers per hour per time. So that would be your slope. And instead of y and x, we're using distance and time. Now let's graph it and tell whether it's a function or not. Okay, so we start at 0, correct? And then every hour, so this is 1, 2, and then 1, 2, 3. Oh, we're counting by hundreds. 100, 200, 300, 400. Okay, so in every hour is 120, so it's probably going to be right there. And then the next hour over, 120 plus 120 is 240, so it's probably going to be right in there. And then remember, it told us up here 360 in 3 hours, so 360 is probably going to be right there. Okay, so folks, yes, this is linear, straight line, and it is definitely a function because we have a constant rate of change. Every hour, 120. Every hour, 120. Okay, so let's look at one more. We have this ant farm down here, and it says it starts off with 22 ants, and it doubles every 3 months. Complete the table. So, folks, we're going to double these numbers. We're going to double this every 3 months. So we have the next 3 months, let's double that. 22 plus 22 is 44. Okay, and then the next 3 months, let's double that number. So 44 plus 44 is 88. And then the next 3 months, let's double that number. 88 plus 88 is 176. See how that works? Okay, so now, is this a function? 0, 3, 6, 9. Yes, because each one of these x values has one unique y value. But is it linear? No, it is not going to be linear. It's going to be non-linear because the same thing is not